Imagine if you dealt with stress by literally melting rocks and launching them into the sky. That's Earth's coping strategy. Beneath your feet, there's this slow, angry soup of molten rock called magma, just simmering, building pressure like a soda can. Someone keeps shaking for a few thousand years. And eventually, psst, boom. Except, instead of ruining your shirt, it builds mountains, reshapes continents, and occasionally cancels flights. So what actually turns a chill mountain into a fiery fountain of doom? Let's peek inside Earth's very explosive therapy session. Earth does not scream when it's stressed, it makes lava. Deep beneath your feet, rock is melting into magma, which is basically a superheated, gooey mix of molten rock and dissolved gases like water vapor and carbon dioxide. Now here's the key. Those gases are trapped under immense pressure, kind of like shaking a soda can, but then burying it under miles of rock. As magma rises toward the surface, the pressure drops, and those dissolved gases start to expand and form bubbles. Lots of bubbles. Aggressive bubbles. Imagine opening that shaken soda, except instead of fizzing politely, it launches flaming rock into the sky. That's an eruption. The magma is forced upward because gas expansion increases the pressure until the surrounding rock can't hold it in anymore. Boom, well, sometimes boom, sometimes more of a dramatic ooze. Either way, what you're watching is the planet releasing built-up pressure in the least subtle way possible. It's not random, it's physics throwing a tantrum. The wild part is that this process can take years, decades, or even centuries to build up. So when a volcano erupts, it's like Earth finally saying, "I've been holding that in since the Middle Ages." You might think every volcano erupts like a Hollywood disaster scene, but some of them behave more like a tired person slowly exhaling. The difference comes down to magma composition, especially how thick or viscous it is. Runny magma, like basalt, flows easily and lets gas escape gently, which means eruptions are more like lava fountains and slow rivers of molten rock. Picture maple syrup flowing off a pancake, except the pancake is a mountain and the syrup can melt your car. On the other hand, thick magma, rich in silica, traps gas much more effectively. It's like trying to blow bubbles in cold peanut butter. Nothing escapes easily, so pressure builds until it explodes violently. That's when you get those dramatic ash clouds and pyroclastic flows that move faster than you can run. So when a volcano is quietly oozing lava, it's not being lazy, it's actually being considerate. It's Earth saying, "I'll just release this slowly so we don't all have a problem." When it explodes, that's the planet deciding it has had enough of your nonsense and flipping the table. Volcanoes don't just pop up anywhere like acne on a stressed teenager. They tend to show up where Earth's tectonic plates are misbehaving. These plates are massive chunks of crust that float on the semi-molten mantle beneath them, and they're constantly moving, just very slowly, like continental bumper cars. When plates pull apart, like at mid-ocean ridges, magma rises to fill the gap, cools, and forms new crust. It's basically Earth doing construction work while leaking lava. When plates collide, one plate can get shoved under another in a process called subduction, and as it sinks, it melts and generates magma that rises to form volcanoes. So every time you see a volcano, you're looking at the result of tectonic drama that's been unfolding for millions of years. It's not just an isolated event, it's part of a massive, slow-motion argument between pieces of the planet. And the eruption? That's the argument getting loud enough that everyone notices. Just when you think you've got volcanoes figured out, Earth throws in hotspots, which are basically the planet's version of a mysterious internal leak. These are areas where super-hot material rises from deep within the mantle, independent of tectonic plate boundaries. The crust above melts, magma forms, and surprise, you get a volcano in the middle of nowhere. Hawaii is the classic example. A chain of islands formed as the Pacific plate slowly drifts over a stationary hotspot. It's like holding a piece of bread over a flame and moving it, you end up with a line of burnt spots. Except in this case, the burnt spots are entire islands made of cooled lava. What's fascinating is that the hotspot stays put while the plate moves, so new volcanoes form while old ones drift away and go dormant. It's less like a one-time explosion and more like Earth running a long-term lava conveyor belt. So if plate tectonics are Earth's arguments, hotspots are its weird internal quirks, no external drama required, just a deep, simmering issue bubbling up from below. When a volcano really goes for it, it doesn't just throw lava, it launches ash high into the atmosphere, and that ash can have global consequences. We're talking tiny particles of rock and glass blasted tens of kilometers into the sky, where they can spread around the planet like a very aggressive dusting of powdered sugar. But instead of making things sweeter, This ash reflects sunlight back into space, which can temporarily cool the Earth's surface. After major eruptions, global temperatures can drop noticeably for months or even years. It's like Earth accidentally turning down its own thermostat after an emotional outburst. Historically, some eruptions have even led to crop failures and what people called years without a summer. So a volcano erupting in one location can affect weather halfway across the world. It's a reminder that Earth's systems are all connected, and when the planet vents its frustration, everyone feels it. It's not just a local meltdown, it's a global mood swing with atmospheric consequences.